Okay, so today we are going to be doing some calculations involving the properties of geometric solids. And so in order to do that, we need to learn about things like the density, the weight versus the mass, the surface area, and things like that. So that's what we're going to do in today's PowerPoint. A geometric solid or a solid is a three-dimensional object, like the examples we have here. Now these aren't actually 3D. We draw them to look 3D, but they've been sketched as a two-dimensional shape. But we're going to use these images to do the calculations for volume and other things in today's activity. So the properties that we're going to be looking at are volume, mass, weight, density, and surface area. And we're going to start specifically with volume. A volume refers to the amount of three-dimensional space occupied by an object or enclosed within a container. And then dependent on which system of measure you're using, the units for volume in the metric system would be cubic centimeter versus cubic inches in the English system. So to calculate the volume of a cube, we would need to know the length of one of the sides of the cube. And the formula we would use is V is equal to S cubed, where V is volume, S is going to be the length of one side, and I will cube that. So in this case, a side length is 4. 4 times 4 times 4 is going to give me a volume of 64 inches cubed. The volume of rectangular prism is calculated by the width, depth, and height of the object. So I need to know these measurements. That's the formula that I'm going to use. And if I plug these numbers in, 4 represents the width of the object, 5.25 is my depth, and 2.5 is the height. Multiply through and I get 52.5 inches cubed for a rectangular prism. Volume for a cylinder is dependent on knowing the radius of that cylinder and the height for that cylinder. So our formula is V is equal to pi r squared, radius squared, times the height. Again, we're going to use 3.14 for pi. We won't show our answers in terms of pi. The radius of this cylinder is 1.5 inches. I'm going to square that, multiply by the height, and I get a volume of 42.4 inches cubed. The formula for calculating the volume of a cone is listed here. Again, I need to know the height for that cone, and I need to know the radius for that cone for this to work. I'll use 3.14 again for pi. Plug in my radius, square that, multiply by the height, divide by 3, and I get a volume of 1.18 inches cubed. So those formulas and other shapes as well are located on the formula sheet, which is loaded in the LMS. Feel free to use that on this activity. A lot of these formulas I think are also in your engineer's notebook, either in the front or the back cover of the notebook has a lot of this same information. All right, let's talk next then about mass. Mass refers to the quantity of matter in an object and is often confused with the concept of weight in the SI system. The units that we use for mass and SI are grams. In the US customary system, the units for mass is slug. Weight, which you are probably confusing with mass, is the force of gravity acting on an object, often confused with the concept of mass within our system. The units for SI are Newton, and the US customary system, the units are pound. So a lot of times people try to use these interchangeably, even though they are not the same thing or represent the same thing. Okay. Our weight is going to be equal to the mass times g, and g is the acceleration due to gravity. Okay. So mass in slugs, if we were calculating pounds, mass would be slugs in the US system, times the acceleration due to gravity, or 32.16 feet per second squared. We were doing this same calculation and we were doing it in the SI system. Our gravity would be 9.8 meters per second squared. Okay, so mass and weight are not the same thing. Weight is going to be mass times our acceleration due to gravity. So an object, whether on the surface of the Earth, in orbit on the surface of the Moon, still has the same mass. What changes is the weight based on gravity. So what I weigh on the Earth is different from what I weigh on the moon because of the differences in the gravity being enacted on my mass. Okay. So each of the measurement systems falls prey to erroneous cultural practices. In the SI system, a person's weight is typically recorded in kilograms, when in actuality it should be recorded in newtons. In the US customary system, an object's mass is typically recorded in pounds, when it should be recorded in slugs. So that's very rarely used by us in the US system outside of in science. So let's talk about density then. Okay. Mass density is an object's mass per unit of volume. So in this case, if we're using mass to calculate the density, we're using mass density, as compared to weight density, which is an object's weight per unit volume. In the SI system, we would be using grams per cubic centimeter, whereas in the US customary system, it would be pounds per cubic inch. So some different examples of materials and what their mass and weight density would be. Oftentimes, you're going to be given this number. So in the activity we do, whether we're using aluminum or wood or cast iron, there is a specific mass or weight density associated with that material, and so those just get plugged into our formula. So if we're going to calculate mass of a solid, its volume and the mass density must be known for that solid. So if this example here, I need to calculate the volume and mass density based on the fact that this is made out of aluminum. So if it's aluminum, it has a density of 2.71 grams per centimeter cubed. I have all the dimensions I would need to calculate the volume. I can plug these numbers in. I'm going to get a mass of 1.59 kilograms. Calculating weight of a solid, its volume and weight density must be known. Okay, again, using the aluminum, 0.098 pounds per inch cubed. I know the measurements, so I can calculate the volume based on the formula that we talked about earlier in this PowerPoint, and I get a weight of 3.60 pounds. So finally, let's talk about the differences then between area and surface area. There is a distinction. The area describes the measure of two-dimensional space enclosed by a shape. Okay, so a 2D shape has area based on what it encloses. The surface area is the sum of the areas of the faces of a three-dimensional solid. So let's look at an example. Okay. In order to calculate the surface area of a rectangular prism, the area of each of the faces of this prism must be known and then added together. So I would calculate the area for each face and add that together. I can kind of envision taking this, let's say, hollow object apart and look at it, what it would be unfolded, right? So calculate the area for each of the faces A through F based on the measurements given here. And then I'm going to total all those up to get a surface area of 136 inches squared. Another way to do that would be to look at the formula that's on the formula sheet that we use. And they do the surface area for a rectangular prism is 2 times my width times depth plus my width times height plus my depth times height. Okay, make sure that you're doing what's in the parentheses first before you multiply by 2. I can use the same example and plug those numbers in. And I get 136 inches for the surface area for this object. Okay. So here's another example, right? 2 times the width times depth plus width times height plus depth times height. Plug my numbers in. I get 88.3 inches squared for the surface area. In order to calculate the surface area of a cube, the area of any of its faces must be known. And the formula I can use then to calculate surface area is going to be 6s squared. So the s squared is going to calculate the area of one face. I multiply it by 6 because there are 6 faces on that cube. And I get a surface area of 96.0 inches squared. And then finally, in order to calculate the surface area of a cylinder, the area of the curved face and the combined area of the circular faces must be known. So the curved face is this where the height is 6 inches represented, and then the circular face is on either side. So this portion of the formula is for the curved face, 2 times pi r times h, the height, plus 2 times pi r squared. This is the area of a circle. and plug the numbers in based on what I have here as the example. I get a surface area of 70.7 inches squared. All right, so let's take that information then and look at today's activity. We're going to be starting activity 5.4, calculating properties of solids. Within the activity, we have two types of materials that we'll be doing calculations for. The first one is a cast iron cylinder. It serves as a counterbalance in the window. The cylinder has a height of 5.25. It has a diameter of 1.75. And importantly, we have here the weight density, 0.259 pounds. So we're going to use that information then to answer these types of questions like the volume of this cylinder, surface area, weight. This is going to be based on calculating the surface area. So we'll go through these questions here. The second one is a rectangular prism, piece of wood. We have a weight density this time of 0.021 for the wood, and we know the size of this wood, and again, calculating volume, surface area, and other things on here. There's also 3 conclusion questions at the end, so you can work directly on this Word document if you want, but I would like for you to show the work for all these calculations, not just to answer. Again, use a color other than black so I can delineate what your answer is from what is already on this page. And when you're done, you're going to save this and upload it to the LMS for activity 5.4. You will have today and tomorrow to work on that before we move on